So question 23, it shows you a graph of sine x between 180 and, minus 180 and 180 degrees, as shown here. And all you have to do is graph what you think sine of x plus 2 is, and you're given the graph of y equals sine x. Well, the thing to notice here is that y is made up of sine x plus this constant 2 each time. So if you know what sine x is, and we have that here, then all we've got to do is keep adding 2 for every value of x that we can put in. So if we try, for example, this would be what 0 would give with sine x, so all we've got to do is add 2, and there's our new coordinate. At 90 degrees, on the old graph sine x, we get 1, but we've just got to go up 2, because we have to keep adding this 2. So we've got 1, 2, and there we go. There's another one. And so on. We can just keep doing that, and all we're really doing is just translating the sine x graph that we had originally up by 2 parallel to the x-axis. So we'd end up with this situation here, like so. Then very carefully, and I've done many videos on how to draw a nice smooth curve, turn your piece of paper around and make sure that you smoothly join the points up. And the best way to do that, and I'll just demonstrate here, is just to turn your page like that, and then with your pencil just draw nice and smoothly through them, okay, like you're under the arc. And then you can turn your paper again like so, and then do the next bit, which I'll try here, and then you can make it nice and smooth like so. Okay, so that's the first part of the question done, and now we've got to do the second part. It says here is the graph of cosine of x, or cos x, for the same interval from minus 180 degrees to 180, as shown here. And all we've got to do is sketch the graph of minus 2 cos x. Now that's reasonably difficult, I would say. Well, we've got to be careful with this one here, so let's give ourselves a bit of space first. Look more closely at y equals minus 2 multiplied by cosine of x. Hopefully the first thing you can see is that the x values are not being played around with at all, they're just being left alone. And what we have here is we have y is still being directly affected, i.e. every y part is being multiplied by negative 2. So the x parts are staying exactly the same, it's the y parts that are multiplying by negative 2. So for example, if we take some coordinates on our given graph of cosine x, say this one's a nice one, we'll call it A, and we'll call that 0, 1. Well, what's happening? The y values are multiplying by negative 2, so that would go to the coordinate. The x stays the same, the y value is now negative 2. So we can plot that one, and we'll have 0, negative 2, and there we are. Now let's try this one here, B, and that is 90 degrees along, 0 up, and that would become, well, the x part stays the same, and the y value gets times by negative 2, but 0 times negative 2 is still 0, okay, so don't be caught out by that. So 90, 0 goes to 90, 0, so that's really useful. And then this one, you've probably got the idea now anyway, so 180, and don't forget this is minus 1 here, that would go to get some more space. That would go to x stays the same. Now, -1 times -2 is 2. So 180 negative 1 would go to 182, which is here. And then we can just finish the others off. So in green, you can see that I've plotted the outcomes here. And I've got the working shown there for you so you can have a look. It's a really good idea to probably do this in the exam if you've got time anyway, or at least do some of them. Now here's the bit of a trick here. Here's not what to do, okay? Right, that's pretty bad because you're losing the sense of the curviness of cos to start with. You know, it's sinusoidal, it's going up and down very smoothly, and you've just shown something there which looks pretty linear here with almost a vertex here, like a point here, and then like a straight line. That's really not good. What you've got to try and realise is that between B and D, for example, here, this curviness of the cosine graph has really got to be preserved here a bit more. And if you see here, between B and C, it's nice and smooth and curved here. So you've really got to be kind of thinking about what would happen here. So if you had something like this here, then you'd probably be looking at something more like this here. Just imagine that this was like the mirror line. So you'd be having something that goes like this, tending through here, round about here, and then up, and then to finish off a little bit above here, and then back to here again. So what I'll try and do is, in a different colour, you know, half of you are probably thinking, what's the point? I'll just do this anyway. Well, I just think if you can make it a little more professional, then the examiner's going to have a little bit more faith in what you're doing. So let's have a look. So I'll enlarge this here, and let's have a look at how this can work. So we'll start from here, and we'll just go forward like so, and then we'll finish this off here, and then follow this round here, and then like so. So you might not think there's much difference there, but you do kind of, you know, keep the sense of what cosine is, okay? So quite a difficult question again. I really don't like these ones to explain at all, but I wasn't just going to like tell you exactly how to do it and just plot the point straight away. I want to give you a little bit of an insight, because if you go on to do A-level, you're going to be doing a lot of these kind of graphs, and you're going to be very submerged into trigonometric functions. Okay, so best of luck with that question anyway. Question 24, quite a difficult trigonometry question. If you're not sure about the area of a triangle, or the cosine rule, or the sine rule, then I have videos which I'll try and annotate on here for you if I can remember. But for this one, I'm not going to worry about this one too much. I'm just going to put an X here and a Y here. I've put the formulae, I've cut and pasted that from the formula sheet at the front of the exam, so you can have a look at that if you need to. I'm just going to get straight on with the question really. So the first thing I would look at would be the area of the triangle. Now, in this case, I'm going to look at this situation where I've got CA and CB making the angle of 40, and then I'm looking at this formula here. The way I try and remember it is, I don't really look at this, to be honest, here. I just look at the two arms that make the angle, and I just say, right, the area is going to be a half times those two arms that make the angle, so 8.4 times x sine the angle that they make. So that's the area, and we know that's 100. So we have some kind of relationship with one unknown, which is x, which is good. So I'll clear that up. And I would get a situation where the area 100 would be, and I'd do a half times 8.4. You can do all of this on your calculator, it's really no problem. I'm going to keep the sine 40 as it is, and I'm just going to put the x here at the front. And then I'm going to divide everything by this both sides, and I'm going to give myself x is 100 over 4.2 sine 40. And I'm not terribly interested at the moment what that value is. I'm just going to keep it because that's a perfect value. It's not rounded at all, it's exact. Now I'm going to use the cosine rule. The reason for that is that although I know x now, and I know this angle, and I know this length, I still don't know what y is, and I don't know this angle, and I don't know this angle. So I'm not going to have enough information using the sine rule. So the cosine rule it is. Now again, I don't really pay too much attention to these. The only thing I do notice in here is there's a nice Pythagoras going on here, and I always pretend that this is the right angle, and that's the good way of remembering it. So I say if that was a right angle, then we'd have 8.4 squared plus x squared, which we already know, and that would be equal to y squared, which is what we want to find. But in this situation it's not a right angle, of course, so what we would need to do is take away 2 times 8.4 times x cos the angle. So that's how I remember the cosine rule anyway. I always think of Pythagoras with a correcting factor, which is always made up of the arms that make the angle in question. So really, all I need to know now is how to put this really into my calculator. So if you put 100 divided by, and put a bracket around this part, 4.2 sine 40, put that into your calculator, and then we're ready to go. So I would like to put the decimal down here for some of you, and in my calculator is sitting 37.0410435 and so on. And all I'm going to type in now is 8.4 here squared plus, and then I'm going to type in ANS, which is this button here on the calculator. It's like so. Some of you may have it, you may not. Squared. And then I'm going to take away 2 times 8.4. So 2 times 8.4 times x, which is ANS again, times cos 40. And that's going to give me this value here. I get 965.8974663, but that's what y squared is. We want y, so we're going to put that to the power 0.5 or use the square root button, and the answer I get for y, and it wants it to 3 significant figures, so I'll put it out as the whole amount on my calculator first, and so on, and then I'm going to round it to the 3 significant figures, so y would be 31.1, and I'll put the units in here, meters, and that is to 3 significant figures. Now for those that are less confident with using the calculator, when you get to this stage here, you can just decimalize everything and just get a value for x, which you wouldn't write like this, and you just keep using this unrounded decimal. What you must not do is to round this to say 37.04 and just use that again, just type in the whole number every time you see an x again that you're going to use again. Okay. Another thing to watch out for is to make sure your calculator is in degrees, and make sure that you know how to use trigonometric ratios like cosine of 40, sine of 40 with your calculator. Make yourself aware of how to do these questions. Get to know your calculator really well. Don't just turn up on the day with a friend's calculator or one that you borrowed from your sister or something. Okay, so lecture over, and that's question 24 finished with. Question 25, I've drawn out a particular way of doing the probability tree, and this is a slow way of tackling this question, and I wanted to do this first because I just wanted to warn students that this kind of question can rob you of a great deal of time in the exam if you tackle it the slow way. So, slow way first. You've got 3 different types of sweet here, and you've got to work out the probability that 2 sweets will not be the same type. So you choose one to start with, a fruit one, and there's 18 out of the 30. And then you could choose a mint one next, which would be 5 out of 29 because you've already chosen one, so there's only 29 to choose from. And then you'd multiply those 2 probabilities. If you're not sure about why you multiply 2 probabilities together, I've got a good video which explains exactly that, and I'll really try and do an annotation here if that would help. So you basically follow that process, and you always look at all the possibilities of getting 2 different types. So mint, then fruit, mint, aniseed, aniseed, fruit, and so on. And you work out all the probabilities here, and then you add all of those up. Now, the bits you can do on the calculator to save time is to do 18 times 5 and get 90. 3 29s is 87, so 30 lots is 870, and you can notice all the denominators will be exactly the same. So what would that give us? Well, on the calculator, I've worked out that this slow way, in fact very slow way, would give us 502 out of 870, which would be absolutely fine. Now let's go to a mediumly slow, if there's such a phrase, a mediumly slow way of doing this. Then here's another way. You could look at F then M, so fruit then mint, and then mint then fruit. Can you notice that you get 90 out of 870 in each case? So what you could do is to cut yourself down a bit of time. You could just do these 2 doubled, these 2 doubled, and these 2 doubled. So you've only got to find one of them, i.e. F then M, and then double it. So what would that give? Well, it would give us 90 times 2 out of 870 plus 126 times 2 out of 870 plus 35 times 2 out of 870. And then, of course, you're going to get exactly the same answer again. But they're the kind of methods you don't want to do for this type of question. To really kill the question quickly and get it over with, and give yourself time to go back over questions in the exam, because this is the last question, and if you ended on a bad note here, then you could severely regret it. So a quick way is to work out fruit and then fruit, mint followed by mint, and then aniseed followed by aniseed. And so the probabilities you'd get would be, for the first fruit would be 18 out of 30, and the next one would be, don't forget you've already chosen a fruit one and you've already chosen a sweet, so it would be 17 out of 29, and you'd multiply those up, and I'll use my calculator here. So I'd get 18 times 17, and that is 306 out of 870, and then I'm going to do the same for the other 2, and this is what you would get. So if we just look at these here. So the first fruit one would be 18 out of the 30. The second one would be 17 out of the 29. And that would give you 306 chances out of 870 of getting 2 fruit in a row. And then the aniseed, and then the next one, don't forget, 6 of them left, 29 sweets left. Multiply 42, and for the mint, the same, 20. And then we get a probability of 368 out of 870. Now, why is that the really fast way? Well, some of you have probably guessed already that if the question said work out the probability that the 2 sweets will not be the same type, and we work out the probability of getting the same type, then we can just say that all the probabilities must add up to 1. So it would be no surprise for some of you to spot that this 368 plus the 502 makes 870. Okay, so if you added the chances of getting 2 the same with the chances of getting 2 different, you would get 368 out of 870 plus 502 out of 870, which is 870 out of 870, which is 1, and that's certain that you're bound to pick 2 sweets. So the quick way is just to do 1 minus 368 out of 870, and then if you've got a good calculator, it will do it as a nice fraction. If you don't have one that will do it as a fraction, it will just give a decimal, which is absolutely fine as well. And you'd end up with the answer again of 502 out of 870. Some of you may ask why I never cancel these fractions. I've always been taught not to do that, because the 870 is a very nice number because it tells you all the total number of choices of picking 2. And if you were to cancel that down to something like 435, the number 435 would not tell you as much about the situation, i.e. the context of picking 2 sweets and how many choices there could be. So that's that type of question. So go for the quick way. I'll be honest with you, when I tried this question in my head, I was going to do it the medium way, i.e. rather slow. I forgot about doing the quick way. But now, hopefully, if I see another one, I'll be reminded and I'll go for the fast way. Okay, that's that question done.